revisited what that language was. We revisited some of our strategies that we have learned about multiplication. And today, we're going to revisit some strategies around division. Multiplication is usually a little easier for us because it's additive, meaning we could add it all up. Adding is usually very easy for our brain. Division can be a little trickier because it's not like adding. It's different. So our title today is going to be Division Language. We're going to be reviewing the language of division. What does that sound like in English? What does that look like? And then we will review some of our strategies. So if you would please go ahead and write the title down. You will need to write these equations, but I would give some space because we're going to be translating them into English. A couple things about my smartboard with division. Remember the division symbol looks like this?
Yeah.
But I don't have that as a key on my keyboard. So when I am writing division for the smartboard, it's going to be a slash. Both of those symbols mean division. I just don't have this symbol on my keyboard. On the EOG, you will see this symbol. You could see the slash, but most of the time they will use the actual division symbol, so you don't need to worry about that. Yeah. All right, so let's look at this first equation. It's been a while. Go ahead and sit up, please. Does anyone want to try? Say it in English. It's been a long time. Sit up, please, Maverick. Thanks. Bowen, you want to give it a go?
27 put into 3 groups has as many.
Yeah, that last part is really tricky. He's got the first part right. We've got 27 things. Could be 27, I'm writing, that means you're writing, could be 27 cupcakes, could be 27 pencils, could be 27 people, 27 things. Put into 3 groups. Then we have our equal sign, which really is just talking about is worth or is means. I'll just leave the equal sign. We've talked about that. That question mark is talking about the number in each group.
Yeah, I know that.
The number of things in each group. Go ahead, 27 things. I put them into 3 groups. And my question mark means how many things are in each one.
In the 3 groups.
So I'll give you some seconds. I know that was a longer definition. Let's try this other one. Over here, I have something a little bit different. This 27 divided by question mark equals 3. What does that mean in English? It's going to be very similar to the one we just wrote down. Are you with us?
It's commutative property.
It's not the commutative property.
Inverse.
It's not the inverse either.
You can't.
It's just similar. Connor, you want to give it a try? 27 things. Does it say 0? Yeah, 27 put into, maybe I use the word some, since we don't know exactly how many. Just some groups, mystery groups. 27 put into some groups. Keep going, Connor, we need the rest of it.
Has the same value as 3.
What does that 3 mean?
How many groups?
So 27 things put into some groups. It's going to mean or equal or be worth. Jordan?
It's the same as 3 things in each group.
The same value as 3 things in each group. Good. 3 things in each group. So if I have 27 things put into a mystery number of groups, it's going to be worth the same amount as if I had 3 in each group. When we are dividing, and honestly, same thing really with multiplication, I'm just making groups. With division, no thank you, Brogan, I'm not taking away anything. I'm just organizing it. It's kind of like if I just gave you a whole pile of Legos. That pile of Legos might look a little crazy until you start organizing it into some groups. That's all division's doing, is we're organizing some big crazy pile, 27 things, into some groups. When we divide, we start with all of it. So in this equation, how many Legos do I have, or puppies do I have? How many pieces of paper do I have? Avery?
54.
I have 54. That's my 54 things. 54. You make up a unit. What do you want 54 of? Putting your hand in front of it and then still drawing is not helpful. Please stop drawing while we're doing this, okay? What do you want 54 of? 54 what, Ava? 54 what? What do you want 54 of? Skittles. 54 Skittles. Paxton, what'd you write? 54 what? Cars. 54 cars. Cole, what'd you write? 54 what?
Legos.
Legos. 54 Legos. Callie, what'd you write?
Markers.
54 markers. Colby, what'd you write? Legos. Marley, what'd you write? Lollipops. Avery, what'd you write? Corn. 54 corn. It's corn. Archer, what you want? What you got? 54 what? What? Emeralds. 54. We'll go with the original. 54 Skittles. Use whatever you got. What am I doing with those 54 stuff? Look at my equation. What am I doing with them?
54, 14.
Look at my equation. It's not a trick question. Well, what am I doing with my 54 stuffs?
Dividing them into 6 groups.
Let's use not the language of divided. Give me some different language to tell me what that means.
Put into 6 groups.
Put into 6 could be stacks. Now, Skittles don't really stack very well, but Legos stack. Maybe 6 piles.
Oh.
Maybe 6 rows. Maybe 6 boxes. Avery? Sure. 54 corns into 6 air fryers. 6. I'm going to use piles, but you could use something else. Look at that.
And go living in a wall.
Is worth.
The only thing I see in the highway.
We don't know. Mystery number. In each group. We've got our skills, our Legos, our emeralds. We put them into our 6 groups or piles or stacks. And now we know that there's a mystery number in each group. So far, so good. We're okay with that? We remember this language a little bit?
Yeah.
Now we're going to get back to, okay, well, we know what happened. 54 Skittles put in my 6 piles. Now what do I do to actually figure out the mystery number so it's not a mystery? Now we're going to get into some strategies. Let's go with my favorite, which is the very first strategy you learn. If you want to make a subtitle, you can. If you want to make a new page, you can. Title it Division Strategies Dealing Out Fees. You can make a new page, or if you want to make it a subtitle, that's fine. But your new title is Division Strategies Dealing Out. Dealing out is my favorite because I've played a lot of card games. I've had to be the dealer in a card game before, and I know what that means. So again, I've got my 12 things. If you haven't written this equation, this is the one we're going to be practicing with. I've got my 12 things put into my 6 groups. So if I imagine this being a card game, I've got 12 cards that I'm trying to put into 6 groups. I've probably got 6 people playing. I'm going to go ahead and draw 6 circles. Why am I drawing 6 circles? Raise your hand and tell me. Why am I drawing 6 circles, Julian?
Because there's 6 people.
Yeah, there's 6 people or 6 groups in this story problem, in this equation. From here, I pretend that I'm holding all 12 of my things. Maybe it's 12 cards. Maybe I'm holding 12 puppies. Maybe I'm holding 12 jackets. I don't know. Now is where I get to deal it out. 1 for you. 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 How many sandwiches have I dealt out so far? Emma? I've dealt out 6. 1, 2, 3, 4, 5, 6. How many do I actually have though?
12.
I actually have 12, so I need to keep going. 1 for you, 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 1 for you. Did I deal out all 12?
Yes.
That's an important part. When you're doing the dealing out strategy, you got to deal it all out. You can't save any. So if I have 12 things put into 6 groups, how many did I have in each group?
2.
2. There is one more thing we need to write down about the dealing out strategy.
How many phones do you need?
Division is fair. So when I was doing my dealing out strategy, notice every single person or every single group got the same number. When we're dealing out or dividing, it's very important that we keep it fair. It would not be fair, Cole, if we were playing a card game and you got 1 card and I got 7. That would not be fair. So we need to make sure that if we're dealing out, that we are keeping it fair. Every person gets the same number. Julian, if you're going to turn the page, turn 1 page, not 17. All right, you got this written down? If you want to, 12 divided by 6 is not a very large number. But if you have a large number, let's pretend you've got, actually we're going to do this one. 72 divided by 9. That's a lot of stuff. When you're dealing out, you can skip count. So instead of starting at 1, I'm going to see if I can give everybody 5. 5, 10, 15, 20, 25, 30, 35, 40, 45. Now I'm at 45. That's way closer to dealing out the rest of my 72.
Wait, do we write that?
No, you don't need to. So when you're dealing out, if you're dealing out a large amount of stuff, if you want to skip count, that's fine. If you'd rather go by ones, that's fine. Both are good options. Doing it by ones takes a long time, but it'll work. So far, so good? We remember this strategy?
Yeah.
Alright, let's talk about another strategy that I don't think many of us use, but could be a good strategy.
Do we write that?
Yep, you need a new subtitle. Division strategy, repeated subtraction.
This is Mason's.
Yep, Mason did like this strategy, you're right. Repeated subtraction. Whatever you're missing with that. Division strategy, repeated subtraction. Yep. And then go ahead and write that equation, because that's the equation we're going to be working with. Now we've got this written. Let's get there. With repeated subtraction, you're going to be pulling out groups. So for instance, I'm going to start with 24. I've got 24 things. And I know that I need 4. At least 4 in a group. Does that make sense? So I'm going to start with 24. I'm writing, that means you're writing. And I'm going to take away one group. One group of 4. Move it to the side. Take away my one group of 4. How many am I left with when I did that?
I need
Callie?
20.
20. I had 24. I took away one group. I've got one group of 4 sitting over here. And I've got 20 left in my pile. So far, so good?
Yes.
I need to keep making groups, though, because 20 is still kind of crazy. So I've got 20. And I'm going to take away another group of 4. Now how much do I have left in my crazy pile? Art? 16. I'm going to keep doing this until I get down to 0 left in my crazy pile. I've got 16. Because if I'm looking at my desk, I want this to be piles of 4. Right now I've got 2 piles of 4 and one giant pile of 16. I want groups of 4. So if I had 16 and I took away 4, how many do I have left sitting in my crazy pile? Addison?
12.
12. I've still got crazy pile. 12 minus another group of 4.
Then you add up all those
Julian?
parts.
8? Is it 8? Yeah, it is 8. You're right.
Oh, then you see it's 4.
Avery? 4.
Now with numbers.
I always like to go all the way down to 0 because then it makes counting my groups a lot easier. Here's a group. 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 And here's a group. How many groups did I make?
On the right side, and the numbers are
Cole?
6.
6. 24 put into groups of 4 means I've got 6 groups.
Right.
6 groups. 4 4 things in each group. I kind of swapped my language a little bit. Does this make sense? Kind of?
Yeah.
Alright, let's look at how they're similar. You do not need to write this down. But how was feeling out similar to repeated subtraction? How is it similar? Samaya?
Take away the number that you have at second, and then you try to get down to 0.
Yeah, so we are starting with a big pile, and we're trying to get down to 0, trying to organize everything. Definitely agree with that. Avery, you want to add on to that?
Could you skip count?
Okay, so it's kind of like I'm writing, but you do not need to write. Connor, sit up. It's like reverse skip counting, right? We're skip counting, but we're also kind of taking away. Bowen, your noise is getting louder, and it's harder for people to hear. Just like Samaya said, we're trying to get our pile, trying to get to 0. We've got this big pile of stuff. We're organizing it, so everything's organized. We've got nothing in a crazy pile. They're now in organized groups. So far, so good. There's one more strategy with division. Because division can be hard to think about. It's hard to imagine that crazy pile and then putting it into groups. It's harder for our brains to do that. Even for adults, it's hard. So sometimes you can rearrange the equation into something that's easier. I want you to write the equation 18 divided by 3 equals box or question mark, whatever you want. 18 divided by 3 equals box or question mark.
Are we writing it down?
Yep.
We don't write the question.
You don't need to write the top part.
No.
Just this equation. 18 divided by 3 equals box or question mark. As we practice, we know this means 18 things put into 3 groups means there's some number in each group. That's hard for me to think about. I'm going to use my opposite operation, my inverse operation, which is multiplication. And I'm going to rewrite it. Now with multiplication, I need to know groups. Do I need to know how many, or do I know how many groups?
Yes.
Yeah, how many groups did I have?
3.
3. 3 groups of how many?
Right.
Do we know how many were in each group? Did I say 18 were in each group?
Blank.
No, we don't know. So 3 groups of a mystery equals 18. Both of these equations are talking about the same thing, but one might be a little easier to understand. For me, it's way easier to think 3 groups of something equals 18 than it is to think 18 put into 3 groups. Does that kind of make sense? Let's try another one. Write 32 divided by 4 equals box or equals mystery. We're going to turn that into a multiplication equation. Do I know the number of groups? Because I know with multiplication I gotta have groups. Do I know the number of groups? Mav, you're over there saying yes.
Yes.
What is the number of groups?
4.
4. I have 4 groups. 4 groups of, like, how many is in each group? Do we know that?
No.
No, that's that mystery right here. So the mystery is just going to be here. It is worth 32. That mystery number is going to be the same in both equations. I've just rewrote it to make it a little easier for my brain to think about. Because for some of you, thinking 4 roots of something equals 32 is way easier than 32 put into 4 groups.
Yeah.
For a lot of people, the multiplication version is easier. And I'm talking about people in the world, not just 3rd graders, regular adults. This multiplication version is easier. Rogan, we talked about this. Nope, I don't want to say if. I'm writing, that means you are writing division strategy. Use multiplication. That's the strategy we just talked about. If you don't want to deal out, if you don't want to repeatedly subtract, flip it around and try to use some multiplication strategies. That will work